Hello everyone, let's get back to statistic again. And today I came up with one more wonderful topic in business statistic called two proportion test in Excel. When we say two proportion test, we are talking about attribute data. Just to recall, attribute data is something which you can count or classify. For example, one proportion test, two proportion test, and chi-square, all it comes in attribute or discrete data, and we're going to take a look on this one. This test, two proportion, speaking about it, is very useful to compare very subtle difference. For example, you have one percentage like 11.1, another case you have 11.2. Whether this is significant or not, we can get to know, right? So we are going to take this scenario and then compare the result, final result in Excel as well as stats.blue. Let's get started. The scenario, here we go. New drug being tested to see if it reduces chance of heart attack. Two groups are created. One group is that drug is given, new drug is given. Another group is that placebo effect. They've been told that they will be all right, or they have a perception that they will be all right, right? So placebo, just to speak about the placebo, and you will get more and more definition to it. So this is also in medical phenomena. The placebo effect is a phenomena where a person physical or mental health improves after receiving inert or dummy treatment or fake treatment like sugar pills and saline injection, fake procedures, and so on. Right? And then one more definition, I've seen it here, the placebo directly from this website. And the placebo effect is when a person has a response to a fake intervention, such as when someone is given sugar pills and they report that it helps with their headache, example, right? So this is the explanation in example. But let's get back to our main topic. So this is the group. So two group. One group is having that drug been given, another group is placebo one. The new drug, this is a claim, right? The new drug seems to have a better result, right? So when you say better result, what we are talking about, right? So just to give you a perspective, so 23 divided by 2219, this is 1, and then we are talking about 46 out of 2035. Okay, and let's take this percentage, 2 percentage, this is 1 percentage. Whether 1 percentage, this is 1 percentage with the new drug, 2 percentage is placebo, whether this has an impact or not, right? Is in these differences are subtle, are vital, are due to chance, all that we can figure out. So whenever we are talking about hypothesis, we are talking about the null and alternate hypothesis. Null hypothesis state of belief that there is no change, right? Absolutely no change. An alternate where I'm bringing my claim, right? New drug seems to be better result, right? That's the alternate one. And if I get the p-value greater than 5%, then I will stick to this one. That means, so the new drug and the placebo are same, or the new drug does not seems to have much influence like placebo and all that, right? So that's what we can conclude. So null mean no change, alternate mean this is what I am bringing new claim that the new drug seems to have better results. And significance percentage 5%. That means in terms of decimal value 0.05. You can go up to 99. That means alpha level. I mean the confidence view on 99. That means 1%, and so on. So, okay, this is the data, right? So, new drug 23, and then sample we have taken 2219, and then we can simply divide this, right? So, this divided by this. So, this 1% you got it, right? So, maybe I'll keep it exactly 2 decimal, I'll keep it 1.4%. You got it. And then let's take another one. So, 46 by 2035. Again, you get almost double percentage, right? So this is 2.26%, right? And then we call it as p hat. P hat is something we can just add this up, b15 plus b18. B15 is what? This one, and b18. So uh, 23 plus 46 divided by 22,219 and 2035. You will get this one is called p hat. And this is a standard formula. Standard error, the standard square root of these two you can multiply directly. Okay, b25 and 26. Okay, so 25 and 26 you can directly, and then you know that how to calculate using this formula square root of p bar 1 minus p bar 1 divided by the number of terms. Right? So, okay, now step number 4, very interesting step. So we can use this formula, normal standard distribution z value, and then you can give truth, right? And then same formula I'm just substituting here. Here I got the z value, right? So this is a z formula, and we got the z value. And using this formula, I'm just applying it here. And then you can just, because we are talking about right tail and all that, right? So this is left tail, right? From there you can get the right tail also as well, 1 minus of that. So this one you can get the minimum, and between these two into 2, because we are talking about two tail. And then the last and final step is that, so this is the final step. So that means, so 0.0016, that means it is very less than 5% for very 0.2 percentage, right? Of course, it is very less than alpha, that is 5%. That means what we are going to do is that if this value is less than this, we are going to say reject the null hypothesis. That means we are going to accept the fact that new drug has an impact. So graphically, if I have to explain, this is the situation. So if you take that, value should be minus 1.96, and the z value we are talking about, and it should be well within this one. And then this is new drug and placebo effect and all that, right? So both have extreme. And then if the value is, the p value is less than or equal to 5, in this case it is true. That means reject the null hypothesis. That means a new drug has a impact, has got the better result. The same thing which you can do it in two proportion test also. Have a click on this also, and it is very useful. So you can give this same number. For example, in our case, we saw that. So here 23 and 46, 23 and 46 to proportion, and then the denominator with 2219 and 2035. There you go. And then you can just simple, and then you also have adjustment, like you can, if you want 5% risk you can do, or if you want 10% you can leave, you can do that. So but I will stick with the 5%. So now you got the n value and the same p value, we got it 1.04 and 2.6, the same value, and the difference between these two is that 1% is the difference. Pool is that, the pool proportion is at 1.6, and then standard error of 1.0039, the same value we have got here. You can see here, right? The same value we have got, and the z 1.96, that is standard value, critical value, and 3 point minus 1 3.6, exactly the same value we got, and the p value 0016, exactly the same value we have got, right? So this is the one, because I have given in the percentage. If you wanted to get rid of the percentage and go back to the 0, you will end up saying this one 0016, exactly the same. Even the decimal is matching. So, and then interpretation, assuming that P1 proportion 1 equal to proportion 2, the probability of seeing the statistic as far as z value is this 1.6%. Conclusion, reject the null hypothesis. Reject the null hypothesis. So 1.6, which is less than alpha or critical value. So this is very, very useful. And then you also get that tiny information also, when to use this sample test and all that, right? So, and then if you really want like a little bit more, like the above guideline for this test are not met, you may use a non-parametric also as well, like bootstrap and all that, right? So you can give your value here. I mean, here I have a resultant value, but if I have a the data set, I can also do that. So I hope you find it useful. Please do like, share, subscribe. You have wonderful.